Hello, welcome to lesson 4B on the perpendicular and angle bisector theorems. So we're going to first look at the perpendicular bisector theorem and its converse. And what the perpendicular bisector theorem states is that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So what that means, according to this diagram here, if I draw a perpendicular bisector, this line right here is the perpendicular bisector. Notice it is perpendicular to these 2 points. I'm going to call these points A and B. And C is the midpoint of those points. It's perpendicular at that point. So that means that both point D and point E are equidistant to both of the endpoints A and B. So AD is congruent to BD and AE is congruent to BE. The converse, on the other hand, says that if a point is equidistant from the endpoints of a segment, then it must lie on the perpendicular bisector of that segment. So if I were to say that AD and BD are congruent, then I know that D must lie on perpendicular bisector CE. So it's true both forwards and backwards. So why is that true? Let's take a look at this here. Here I have drawn really basic perpendicular bisector. AB is being bisected by line segment CD. And when I look at this, if I were to draw in AD and BD, I note that if this is 90 degrees, this is also 90 degrees, and they share this reflexive side CD, which means that triangle ACD is congruent to triangle BCD by side angle side. And because they are congruent, that means that segment AD is congruent to segment BD because corresponding parts of congruent triangles are congruent. So I can conclude that these two segments are congruent. That's why the perpendicular bisector theorem works. So, moving right along, let's look at some examples of how we can solve this. This is that converse example. I'm given that AD and BC are equal and that angle C is 90 degrees. Therefore, I can conclude that AC and BC are congruent because D must lie on the perpendicular bisector. Therefore, DC must bisect segment AB. So what I can say then is that x squared must equal 4x minus 3. And I can actually solve this equation. Y'all learned how to do this in Algebra 1. I'm first going to get everything on the same side as the x squared because that is a quadratic equation. And then I'm going to solve it by factoring. I want two numbers that multiply to positive 3 and add to negative 4 to split this middle term. I like minus 3 and minus 1 for me to be able to split that term. Notice those still add to negative 4. I'm then going to factor by grouping. I can take an x out here to get x minus 3. I'm going to take a negative 1 out here to get another x minus 3. And I like that now because those match. So that becomes x minus 3, factor that out the front, times x minus 1. All of these still equal 0. So that means x minus 3 equals 0 and x minus 1 equals 0. Therefore, x equals 3 or x equals 1. All right, guys, let's take a look at the next example. Here we're going to find both x and y. So we're going to have to do a system of equations. And in order to do that, I need more space to write because my handwriting's really big. I'm going to erase what I have here, but I want to make sure you guys have this in your book before you do. So make sure it's all written down before I erase. All right, let's look at this next piece. Here we have, again, a perpendicular bisector. So I immediately can pull from this that 2x plus y is equal to 8. That's an easy equation to pull. And then I can also conclude, because DC is acting as a perpendicular bisector, these pieces must also be equal. AD must be congruent to DB. So I also know that 3x plus y is equal to 10. Now I've got two variables and two equations. We call it a system of equations. And I think the easiest way to solve this, because I've got a single y in both, I'm going to send a negative through my top equation and just add straight down. I'm going to solve by elimination. So my y's are eliminated. 3x plus negative 2x just gets me x. Negative 8 and 10 gets me 2, so I get x equals 2. I'm now going to plug that into one of the two given equations. I'm going to do the first one. 2x plus y equals 8, or 2 times 2 plus y equals 8. 4 plus y equals 8, so y must be 4. So my answer is x equals 2 and y equals 4. Since those are x and y, the point 2, 4. All right, let's look at one more example. We're going to look at a city planning grid. The library is located at point 4, 8 on my city planning grid. So I'm going to put a point at 4, 8, which is way up here. And City Hall is located at 0, 0. So down here is City Hall. I'm going to call that C. So I've got Library L and City Hall C. The fire station needs to be equidistant from these two locations. Draw a line on the grid designating all points where the fire station could easily be placed. All right, so if I want the fire station to be equidistant from these two locations, the fire station needs to be on the perpendicular bisector of the line to the line that connects City Hall to the library. So my first step in finding the perpendicular bisector is really just to find the midpoint of that segment. So my midpoint is always the average of the x's, 4 plus 0 over 2, and my average of my y's, a plus 0 over 2. We've done this a lot at this point, guys. Or 4 over 2, 8 over 2, which means that the midpoint is really at 2, 4. And so when I look at 2, 4, oh, look, guys, that's on the segment. All right, so the midpoint would be the closest point between the two, but I want the line that designates all possible points. So what I need now is something to make that perpendicular. So I need the perpendicular slope. Well, the slope from C to L from this is really the difference of the y's over the difference of the x's. And my y's, it's 8 minus 0, and then my x's are 4 minus 0. So I get 8 over 4, or my slope is 2. Which means the perpendicular slope is always the opposite reciprocal. So I make it a reciprocal by turning it into a fraction and opposite by putting a negative. So that means I want a slope of negative 1/2 from this point. So if I go down 1 over 2, and then I can reverse that from here too, this is the line we could draw on our map of all the possible locations for the fire station. All of the points on that line would be equidistant from between C and L. They're not all equally close, of course, but they're all equal distant from point C and point L. So that's the answer to that question. All right, let's talk about angle bisectors. The angle bisector theorem states that if a point is on the bisector of an angle, then the point is equidistant from the sides of a triangle, or sides of the angle, sorry. If a point is, whereas the converse says that if a point is equidistant from the sides of the angle, then the point must lie on the bisector of the triangle. So let's look at some examples here. Here I'm going to call this angle ABC and this point D, so that ray BD is bisecting angle ABC. And what happens then is that DE and DF then end up being congruent, because that's the segment that would be the smallest distance from point D to line AB and point D to line BC. Those two segments end up being congruent. Remember, guys, that the shortest line you can draw from any point to a segment is always the perpendicular line to that segment. So let's figure out why the angle bisector theorem works. So here, all I've got is that FG is the perpendicular bisector, and that angle GIF and angle GJF are both 90 degrees. That's all I know. So things I know. First of all, I know that FG is congruent to FG between these two triangles because they're reflective. So when I look at this, this means I've got an angle, and a side. Therefore, I can say that triangle IFG must be congruent to triangle JLAC FG by the AAS theorem, because I've got two angles on the side that are congruent. So because they're congruent triangles, I can then say that GI is congruent to GJ by CPCTC. I know then that these are congruent. Therefore, we have proven in a very shorthand method the triangle angle bisector theorem. Now let's look at its converse. What if I know that these are 90-degree angles and that these two segments are congruent? I now want to see if I can prove that FG is the angle or the angle bisector. So things I can add to my diagram real quick. We've got a shared side, FG, just like before. Therefore, now I've got I've got side-side angle, which isn't a way to prove, but this is a right triangle, which means that this is a hypotenuse and this is a leg. Therefore, I can say that triangle FIG is congruent to triangle FJG by HL. And because the two triangles are congruent, I can now say that these two angles are congruent. Angle IFG is congruent to angle JFG by CPCTC, because corresponding parts are congruent, triangles are congruent. And if those two angles are congruent, therefore FG, ray FG, bisects angle IFJ. So we can say that FG is the angle bisector. So that's why the converse is true. So let's look at some examples of how we can actually use this. Here, this is marked as an angle bisector, right? FK is acting as an angle bisector. And because FK is an angle bisector, I know that these two segments must be congruent. So I can say that 3x minus 8 is equal to 2x plus 6. And I can now solve this really fast for x. I take the 2 over there to get x, add the 8 over there, I get x equals 14, and we're good. Let's look at this one down here. Here, this is again marked as an angle bisector, and point G therefore must be equidistant to the sides of this angle. Therefore, I know that these two things here are congruent. So I can say that x squared is equal to 4x plus 5. And we can solve that. Because it's quadratic, I bring everything over to the other side. X squared minus 4x plus 5 equals 0. It's quadratic. I want two numbers that multiply to 5 and positive 5 and add to negative 4. Oh, that should be a minus 5. I'm sorry, guys. That's what I did wrong. That should be minus 5. All right, so I like negative 5 and positive 1. So that become x squared minus 5x plus x minus 5 equals 0. We factor by grouping, first two, last two. I'm going to take out an x here to get x minus 5. Here there's nothing to take out, so I'm just put a 1 out front to remind me that I'm going to deal with the 1 here. I've got x minus 5s in both positions, so I get x minus 5 times x plus 1 equals 0. Set both of them equal to 0. So I get x equals 5, or x equals negative 1. I need to make sure both of these are actually going to produce real results. If I plug in the negative 1, this becomes positive 1, and this would also be positive 1. So actually, I can keep both of these solutions. So they are good to go. All right, guys, that is the end of this lesson. Please take a look at the MML practice, and we will talk in class. Thank you so much.